Okay, today financial modeling guys, we're going to talk about key rate duration once again. So I'm going to do an example now on this video so you guys will be comfortable going to the text next week, okay? So once again, let me remind you what is a formal definition of a key rate duration. So if you have a portfolio, right, of bonds. Now, this portfolio, okay, it can depend on the entire curve. Let's say this is my curve, and these are the points on the curve, right? These are interest points on the curve, yada, 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 until yn. Okay? The definition of the key rate duration, the nth key rate duration of the portfolio, is just going to be 1 minus 1 divided by the price, the total price of the portfolio, times delta P to delta yi. Okay, so you can think about this price as this portfolio of bonds as having a function of y1 to yn, which is a price, right? And then you define this guy, which is basically going to be the sensitivity, okay, of your price to a certain move here of the yield curve. So if only one more point moves, that's going to be your derivative, right? So, for example, if yi moves up by 1%, okay, you will know exactly what will be the return of this portfolio. It will be basically key rate duration I times 1%, and don't forget to put the minus here. So, that's all there is to it. Now, if P is a portfolio of zero coupon bonds, okay, then okay, you can actually skin this cat in the following way. You can say that if I have a zero coupon bond, let's say I have a zero coupon bond that matures in time t, okay, say t is going to be 2 years. However, you do not have the 2-year point as parts of your points collection on the curve, right? So what you can do, for example, you have the first point and the third point, okay? So what you can do, you can actually write the equation of a zero coupon bond like this, times 2, okay? This is going to be the equation of a zero coupon bond which matures in 2 years as a dependence on y1 and y3 on this point and on this point. Now, what will be its key rate duration? Because it has two exposures to 1 and 3, right? It doesn't have an exposure to 2. Okay, because that's what we demanded, that's what we requested, right? Then it's going to be two guys, right? It's going to be delta P 2 to delta y1, 1 over P2 with a minus, right? Here, and the minus 1 over P 2 delta P to delta y3. Okay? Now, if you derive, you're going to see very clearly, right, that this is going to be 1 and this is going to be 1. So what happens here? What happens here is what actually always happens with key rate duration for zero coupons. So you have the following diagram. Here you have your timeline. This is your timeline. This is going to be, right, your zero coupon bond, which is going to be 2. However, you do not have this point here. Right? So this point is actually distributed between these two guys. This is going to be 1, and this is going to be 1. Okay? Now, you have to face the fact, okay, that in today's job market, in today's market, fixed income professionals are not just using durations, they are actually using also key rate durations. Okay? There is nothing to be done against it. I mean, perception is reality. I agree, the duration is enough for 95% of the time because the curving usually moves in parallel, okay? But people want more granularity, and that's why you have to master those kind of pictures. I know that it's not easy, but it is what it is. All right? So here, right, your key rate duration, your 2-year, right, is split between 1 and 1. Okay, so it means that if Y1 or Y3 will move by 1%, you're going to lose, right? Not 2% as because of your duration, but only 1%. And if this guy is going to move up and this guy is going to move down, you are going to be price neutral. Okay? So that's the crux of it. That's that's the explanation for key rate duration. When you are going to think about risks, okay, and you're going to think about sensitivities, key rate durations are your man. All right? Thank you very much and have a great day.